Hello there, Mr. Sutton here, bringing you the Algebra 2 7-2 Part 1 homework solutions on graphing rational functions in transformation form. For all of these problems, they want us to graph the transformed function. So we're starting with the parent function 1 over x, and we're supposed to graph g of x, and they also want the domain and range. So in all these cases, we're going to start by figuring out the transformation that's happening, writing down the parent table, and then figuring out how we need to change x and y and the asymptotes in order to regraph this thing. So since we have this plus 5 in the denominator, that's going to be shifting us left 5. The plus 2 outside the fraction shifts us up 2. So we have a translation of left 5 and up 2. So writing down my parent table now, we've got -1, and 1, 1. And for my g of x table, since I'm going left 5, I have to do x minus 5. And up 2 means I have to do y plus 2. So we've got -1 minus 5, which is -6. 1 minus 5 is -4. -1 plus 2 for the y values gives us 1. And 1 plus 2 is 3. Now for the asymptotes, we start originally with x equals 0 for the vertical asymptote. Since we're subtracting 5, we now have x equals -5. For the new vertical asymptote. And we started with y equals 0 for the horizontal asymptote. Adding 2 to the y values now gives us y equals 2 for the horizontal asymptote. Graphing all this out, and I'm going to be over toward the left of my axis here just so I can fit these fairly negative values. So we've got our asymptotes, x equals -5 right there, and also y equals 2, this horizontal line here. Next up, we have our points, -6, 1, which is right here. And -4, 3 is going to be up here. So we have one branch in the lower left here, and another branch in the upper right. And like we're going to be doing on all these problems, we are approaching the asymptotes and going through the one point that we have in each of those spots. Now for the domain, that's always going to match the asymptote. For the x value there, so the vertical asymptotes will have x does not equal -5. And for the range, that always matches our horizontal asymptote on these, so we have y does not equal +2. For this problem, to graph the transformation, all that's going on this one is we have a 4 up here in the numerator, so that's going to be 4 times the function basically, so a vertical stretch of 4. Our parent function, we've got -1, -1, and 1, 1 for our 2 points. And for the g function, since I have a vertical stretch, that doesn't affect my x values at all. So those are still going to be just whatever x's I started with. For the y values, I'm doing 4 times y. My x values are still -1 and 1. For the y values, now I have -4 and +4. And since I didn't shift this or translate it at all, my asymptotes stay x equals 0 and y equals 0. Graphing all this out, since I have my two asymptotes are literally the y and the x-axis, I don't have to draw anything special for those. I will put in my points though. So we have -1, -4 down here, and 1, 4 is right here. So we have one branch going like so in the lower left, and another branch in the upper right going like this. For the domain and range, those are going to be the original domain and range of x not equal to 0 and y not equal to 0. For this problem, we have a -9 in the numerator of my parent function. So that is giving us two things. First off, we have a vertical reflection and also a vertical stretch. So here's my parent table, -1, -1, and 1, 1. For the g function, I'm not doing anything horizontally, so my x values are still going to stay the same. I don't have to change those. For the y values, I have to multiply those by -9, so -9. So my x's are still -1 and 1. For the y values, -9 times -1 is +9, and then this +1 becomes a -9. Since I didn't translate this at all, my asymptotes are still going to be x equals 0 for the vertical one and y equals 0 for the horizontal one. Graphing all this out, since my x and y asymptotes here are just the x and the y-axis, or the y and the x-axis technically. I don't have to draw anything special because I've already got the axes to guide my graph. I do need to put these points in though. So we have -1, comma 9 right up here, and 1, comma -9. So in the upper left, I've got one branch going like this, and in the lower right, we've got another branch going like that, approaching the x-axis. For the domain, we've still got x not equal to 0 because of our vertical asymptote. For the range, we have this horizontal asymptote at y equals 0, so y cannot equal that. To graph this transformation of the 1 over x function, let's see what's going on here. We have a 4 times the original function, this 4 in the numerator. That gives us a vertical stretch. And since I'm adding 3 outside the fraction, I'm translating this function up by 3. So let's implement this. First off, let's do our parent table. That's -1, -1, and 1, 1. And now my g function, for the x's, I'm not doing anything in the denominator here, so we still have just regular x for that rule. Nothing changes there. For the y values, however, the stretch and the translation, well, the stretch comes first, so I have to do 4 times the y values, then I have to add 3. So 4y plus 3. For my x's, I've still got -1 and 1. For the y's now, we have 4 times -1 is -4, plus 3 is -1. And then 4 times 1 is 4, plus 3 gives us 7. Since I shifted this thing up by 3, that's going to affect my horizontal asymptote. I didn't shift it left or right though, so my vertical asymptote is still x equals 0. But the horizontal one now is going to be 3 higher than it was before, so it's going to be y equals 3. Graphing this out, I don't have to do anything for my vertical asymptote because I've already got the y-axis drawn here. For the horizontal though, I have to draw a line at y equals 3 right here. And now for my 2 points, I've got -1, -1, which is right about here. And 1, comma 7 is my other point, so over 1 and up 7, grid lines going by 2's here. So my first branch is in the lower left like so. And then in the upper right, I've got my second branch. For my domain, that's still going to be x not equal to 0 because of my vertical asymptote. The range, since my asymptote's at 3, I've got y not equal to 3 for that one. For this one, I have a few things going on transformation-wise. The 4 up here is giving me a vertical stretch. The -3 downstairs is giving me a shift of 3 to the right. So vertical stretch and translation, right 3. For my parent table, I've got -1, -1, and 1, 1, because this is the 1 over x function. For my g table now, for my x's, since I'm going 3 to the right, I have to do x plus 3 for that rule. And for the y's, this stretch here is going to make me do 4 times the y values. So we're changing the x's and the y's on this one. Kind of exciting. So for my x's, I've got -1 plus 3, which is 2, and 1 plus 3 is 4. For the y's, we have 4 times -1 is -4, and 4 times 1 is 4. For the vertical asymptote, since I'm shifting 3 to the right, I have to add 3 to my asymptote, so we have x equals 3 for the new vertical asymptote. Since I didn't do any vertical shifting, however, I didn't go up or down at all, that means that my horizontal asymptote is still y equals 0. So putting all this on a graph, my new vertical asymptote at x equals 3 is going to be right here. For my horizontal asymptote, y equals 0 is the x-axis, so I don't need to draw anything special for that. For my first point, we've got 2, -4, which is right down here. And 4, 4 for the other point is up here. So my first branch in the lower left is going like so through that point. And in the upper right here is my second branch. For the domain, since we shifted our vertical asymptote over to 3, we have x not equal to 3 for that domain. The range, since we didn't move the horizontal asymptote at all, the range is still going to be y not equal to 0. For this problem, we're trying to graph this transformation of the 1 over x rational function. Let's take a look at what's going on with this mess over here. So we've got a few things happening vertically. The negative gives us a vertical reflection. The 3 up here gives us a vertical stretch. So we have a stretch and a reflection vertically. The +2 in the denominator is shifting us 2 to the left. So we have vertical stretch and reflection, translation of left 2. All right, let's start with our parent table. We've got -1, -1, and 1, 1. And for the new table here, since I'm going left 2, I have to do x minus 2 to represent that. And since I'm doing this -3 up here, I have to do -3 times the y value. So that gives me a vertical reflection and stretch. For my x's, -1 minus 2 is going to be -3. 1 minus 2 is -1. And for the y's, -1 times -3 is 3, and 1 times -3 is -3. Since I went 2 to the left, that means my new vertical asymptote is x equals -2. I didn't shift up or down at all, so my horizontal asymptote is still y equals 0. Putting this on the graph, we have our new vertical asymptote at x equals -2 right there. The horizontal asymptote is on the x-axis, so I don't need to draw anything different for that. My first point, we've got -3, 3, which is right about here. And -1, -3 down here gives us our other point. So we draw our first branch through that first point, approaching those asymptotes. And here's our second branch in the lower right. For the domain, that's going to match my vertical asymptote, so x not equals -2. And range, then, we're going to match the horizontal asymptote of y not equal to 0.